Greetings and welcome, friends. Mr. Waddy here. We're taking a look at last night's quest. We were talking about similarity transformations, and it's going to be amazing. Just you wait. Here's question 5. If you don't know how to do question 5, Big Ideas recommends the idea of seeing example 1 first. Might be a good idea. Es un buen idea. So let's see. Let's plot some points. Here's F is at -2, 2 right there for F. G is at -2, -4. Friends, we tracking with you? Come on now, friends. Right? G is at -2, -4. Oh, I went the wrong way. You guys would have saved my mistake, though, right? You would have corrected me. Faithful are the wounds of a friend. Let's see. H is -4 and -4. Friends, guys, track with me here, friends. Come on. So, here we go. So let's draw this triangle. We are going to do a rotation by 90 degrees. Now, someone was talking about, just moments ago, the way you can use like the opposite, the A and the B of the X and Y coordinate to do those rotations. Does anyone know how to manipulate the coordinates to accommodate a 90-degree rotation? -BA is what I'm hearing. So A comma B, you're claiming is going to become -B comma A. Is that the claim for a 90-degree rotation? All right, let's see if that works out. So so here we go, 90 degrees out. This was left 2, down 4. So I think I'm gonna go right 4, down 2. That looks like 90 degrees. You believe it? I believe it. So I think that G prime is going to be right here. Let's see, I'll leave that right there. There's my G prime all the time. How did those coordinates relate? So here's 4, -2, and this one was -2, 4. Did that work out? -2, 4. I would have flipped them. No, I don't think -BA works. Is it just B and then A? I did do counterclockwise. Oh, with the save. All right, thank you, friends. Now it's going to be on the internet forever. Mr. Waddy makes mistakes, so that's fine. But here we go, Lauren, right? We've got, I made a mistake, -2, -4, and then that became +4, -2. Good job with the save. Thank you, friends. So, we could do the -BA thing for all of these. So this would be +4. Wait a minute. +4, -2. Oh, that's the one that I just did. That's why guys, I need your help here today, apparently. Let's see. So let's see. This one would be -2, -2. So -2, -2 is a rotation. That's F prime. Does that seem to make sense? Yeah, that's 90 degrees in the counterclockwise direction. All right, so there's F prime. And H prime would have been +4, -4. So over 4, down 4. Right, Malik, you with us? And so there we go. Let me get the diagonal line for that because I'm done gonna mess up my diagonal. We assume if it just says 90 degrees, it's counterclockwise. All right. Someday in maybe Algebra 2 or Pre-Calculus, if I ever teach it to you, I don't know if they do now, I might communicate why historically mathematicians have made that choice for angle rotations, but it is not this day, is what Aragorn would tell you. It is not this day. Let's see. Now I'm gonna dilate this by a scale factor of a = 3, right, Isaiah? So and this dilation is also assumed to be at about the origin. Okay, if they didn't say. So here, this point is 2 units away. So I'm going to triple that out, and it looks like F double prime is going to be all the way out here. You guys agree? I also could have done that by taking the coordinates of F prime and multiplying each of those by 3. So here's -2, -2. Triple that, it's going to be -6, -6. Same result either way. Here, let's see. So G is at 4, -2. Triple them. It's going to be at 12, which is actually just past my grid, and down 6. 1, 2, 3, 4, 5, 6. All right, so right there is going to be G dub prime, like so. And let's see for H. You guys with me? Hello? Come on now. Come on. We got that test today. I want to help you out. H double prime. It's okay. It's like the best awkward silence the internet has ever heard. That awkward silence will be edited. It will be clipped. It will be like dubstepped. It will be like auto-tuned. And it'll be no. Auto-tune the silence? Oh, it'll be amazing. That'll go viral. It'll be the best silence you've ever seen, ever heard. You can't see silence. I know. Let's go. H double prime. So let's see this one. Here, I'll show you another way to do it. This one's down 4 over 4. Let me just triple that slope, friends. Down another 4, Haley, over 4. Down another 4 and over 4. Looks like I'm right here just off the grid, which is where, I don't know, some Vermonters choose to live, just off the grid, right? Maybe you've got your own like solar panels and rain collection bucket. Yeah. Oh man. So So yeah, so here we go. Here's the final product. And it is 3 times the size linearly. How much larger is it in terms of area? 9 times the size. This will fit 9 of those green or orange triangles. Jack, you had a question, comment? Yep. You're correct. Yeah, we couldn't just multiply the coordinates. So if I was like dilating from here by 3, I'd have to be like, okay, this is 2 units to H prime. So then 2 and 2, this is where the new H double prime would be. So yeah, you'd have to, exactly, good question. Or if I was dilating from F prime, this is down 2 and over 6. And if I was dilating by a factor of 3, I'd have to then go down 2 and over 6 and down 2 and over 6 again and get my new point. So yeah, sometimes we do dilate from points that are not on the origin. I don't remember. I don't think so. Let's see. Probably. But question 7. Describe a similarity transformation that maps the blue pre-image to the green image. All right. Step 1. What's someone got for a step 1? Josh. Okay, so dilate in which K is equal to 2, you're saying? So the blue image, so this is now F prime is going to be here. Let's see, down 2 over 1. And so down to another over 1. E prime is going to be right here. And then let's see, down 2 over 3. So down 2 over another 3 right there is my D prime.
Oh no, okay. No.
Translate. Let's do this component form. Why not? Because we haven't done that for a little while. That would be 0, 1. Right, Jack?
Yeah.
0, 1. Yeah, there you go. There we go. We've got like, I don't know, It's a great pumpkin. All right, last question. Prove that the figures are similar. All right, we got to pick up the pace. We're behind time. Okay, so you said step 1, reflect. Let's reflect over, I'll reflect triangle ABC over the line AB. Does that make sense? So let's see. So that would land, let me pick a different color here. Right here. And then translate. Okay. Let's translate it. So that A maps onto R. You guys like that idea? Okay, so let's see. I'll make this time so that it's going to go like this, and it'll look something like that. There we go. And now what do we need to do? Dilate. By a scale factor of what? Yeah, what do you think, Josh? Of, and it's image over pre-image. I think he's got it. K over J. And who asked the question about non-origin dilations? About which point? About point R. I like it. And since it maps onto the image, then the triangles are similar. Actually, I'll even show you some new math lingo right here. Ready? It's kind of like congruent, except less congruent. That's, yeah, similar. That's also similar. Not equal to is this, equal to is that, similar is that. When it's both, look at this. When these two had a baby, it was congruent. Yeah, there you go. Thanks for watching, Internet friends. Have a great day. And thank you for listening, local friends, my IRL friends.